So we're a slightly older company, I think, than most here. So I'll focus on kind of what we do and what we've achieved so far with some of the pilots that we completed. So we manufacture IoT sensors, so be it air quality or a range of different types of occupancy sensors, with one goal: to automate buildings, to have them reduce the energy consumption, improve indoor air quality, improve comfort, with something that the industry calls demand control ventilation. That's kind of the main thing that we try and push forward in the industry. The type of buildings that we target, you'll see later in the case study, is our large buildings with full HVAC systems and a building management system. And the purpose is to make our journey through retrofit very simple for existing buildings, because most buildings are already built. And even the ones that are going to be built are sometimes left with no sensors inside, because they get value engineered out, because sensors are the last things that go in. So some of the benefits of retrofitting these back in is that you do get quite high savings on the HVAC systems by running a building on how it's actually being used by people. With the way that we've architectured our system, you get a pretty quick payback because the install is relatively cheap. And in addition to what kind of sensors you get, we also help provide the kinds of control strategies that are relevant for different types of buildings. So we can improve comfort as well as reduce energy consumption. So one of our sensors is here, and as you can see, this room does not have mechanical ventilation, and we will be spending our time breathing in each other's air. Great, have fun. Nobody knows that, but that is what happens. So we've got a number of sensors that are wireless, some that look like this, others different, some that are locally powered, and they collect air quality data, some occupancy data, and transmit that to what we call kind of our base gateway controller, which acts as a sensor itself, detecting the levels of occupancy, but also sends data to the BMS, takes data from the BMS, and sends data to the cloud so that we can monitor what's going on with our system, making sure the sensors are calibrated, and monitor what happens with the actual BMS and whether it's working or not. This is an example of how a building floor is occupied during a couple of months or 1 month. And you can see people don't come in to work on Fridays. There are tube strikes which prevent people coming to work. So there's a very dynamic environment in most buildings, especially since COVID. So it really needs demand control ventilation to be implemented to save energy and improve comfort. One of our case studies is with Transport for London, one of their buildings, which is 250,000 square feet. We were able to implement this with a project cost of about £100,000, which included money for helping their BMS to kind of be a little bit renewed and taken care of better than what they had done with their incumbents in terms of the management of the BMS. We are saving them £182,000 per year, which is a 7-month payback. And now they were paying 30p a kilowatt hour, which is relatively high nowadays. But even if you're paying 20 or 15p a kilowatt hour, you can get a 1 to 2 year payback quite easily, depending, of course, what's inside your building. And part of our services helps to understand how demand control ventilation could work for your building, as well as providing sensors for perhaps those companies that already know how to do this stuff, but just looking for a novel way of getting that done.